a previous video, we looked at the multiplication properties of exponents as well as what to do with the zero and negative exponents. And today we'll look at what the division properties of exponents are. There's only a couple extra things to do if we've already done all the rest of the properties. So one of them is quotient of powers. So the idea with the quotient of powers is that instead of having things that are next to each other, like we did whenever it was a product of powers, we have something on top of a fraction and something on the bottom of a fraction. I picked a really big number here on top on accident. So they're saying that there are 7 9s on top, 9 7s. Whoops. So that's 5, 6, 7, 8, 9. And on top there's 2 7s. So the idea is that each of these on top and bottom that we can pair up would go away, like this 7 and this 7 would cancel, this 7 and this 7 would cancel, and so what we're left with is 7 7s, and we're okay typically with leaving that answer and not having to actually multiply it all out. What we just did, if we look at our exponents up here, how do I go from 9 and 2 to 7? We actually subtracted our exponents. So what's going to happen is that we'll do the top exponent minus the bottom exponent. Now sometimes what happens with that is that we'll get a negative exponent. So for instance, this is 3 3s on top and 6 3s on bottom. And so if we pair up and cancel out, well, that was a bad mark on my part, then we have 3 3s left on the bottom. So this is 1 over 3 cubed. Well, we get that when we subtract our exponents if we say, well, 3 to the 3 minus 6 is negative 3. And then we have to remember our rule that we don't want to leave things with negative exponents. We want to move those down to the bottom. So that's how we end up with this 1 over 3 cubed. Now 3 cubed is actually a pretty small number and would be easy for us to figure out as opposed to 7 to the 7th. So we want to, when we see that we have the same base on top and bottom, we want to subtract the exponents and then put it on top. Or another way of thinking of it is when I look at a problem like this, I say, okay, I'm going to subtract these and get 3, but I'm going to put it on the bottom because there were more 3s on the bottom. And that way I don't have to actually write it with a negative exponent and then move it. So it's up to you which way makes more sense. And then our power of a quotient works like our power of a product did, where if I have parentheses, everything inside gets that cubed power as long as all we have is multiplication and division. So this would be 2 cubed over 5 cubed. We can figure out what both of those are really easily. It would be 8 and 125. So that would be our answer. So our rule is that x over y in parentheses to the a becomes x to the a over y to the a. And then the biggest thing here is to remember that we always want to leave our answer or make our answer have positive exponents. So if we end with something and there are negative exponents, we're not actually done until we move things around so that they're positive. Let's look at some examples. Example 1 says evaluate the expression and asks us to write fractions in simplest form. So the idea when we see the word evaluate is that we want to actually figure out what the answer is. So we will use our quotient power rule thing and say 6 to the 8th and 6 to the 5th. I'd subtract my exponents and get 6 cubed. And then we want to figure out what 6 cubed is. 6 squared is 36. Then you times it by 6 again, and you get 216. So that is our answer. On part B, what's interesting here is on top the negative is not in parentheses. On bottom the negative is in parentheses. If I take a negative 4 and raise it to an even power, then this negative will go away. But this negative that's on top is not being raised to a power at all since it's not in parentheses. So this negative is going to stay and is going to make our whole thing be negative at the end. once I've worked out where our negatives should go, now I have 4 to the 4th over 4 to the 6th, and these now are like bases, and I can subtract their exponents. So I can say that this is 4 minus 6, which is negative 2, and then that tells me to move it down to the bottom. That means that I have negative 1 over 4 squared, is moving it down to the bottom, made my exponent positive, and then that gives me negative 1 over 16. I'll just remind you that these negatives that are here at the beginning are not the same as having negatives in our exponent. The negative in this exponent does not affect the negative that's outside. All the negative in the exponent does is tell me to move the 4 down to the bottom and then square it. So the better thing to do with negatives in front of our numbers is to see if we can deal with them as kind of a separate problem and say, okay, I've got a single negative up on top, but on bottom this negative is really 6 negatives, which all cancel each other out, and I'm just left with the negative that was on top. That's probably one of the hardest things on stuff like this, is dealing with whether overall our answer is negative or positive. Example 2 says simplify the expression, which just means that we'll probably have x's. We won't actually be able to evaluate and get an answer that's a number. The simplified expression should have no negative exponents. So whenever I do negative and then inside parentheses I've got negative x over 7, I'm squaring this. Everything inside my parentheses needs to be squared. And so the negative right here, if it helps to pretend like this negative is really a negative 1, negative 1 when I square it turns positive. So the negative inside is going to go away. Then I would say x needs to be squared and 7 needs to be squared. And we'll go ahead and say that this is negative x squared over 49. On B, everything inside needs to get the negative third power, but we actually can do this in 2 different ways. We could go ahead and simplify what's on the inside by subtracting our exponents and then raise it to the negative third. Or we can go ahead and move the negative third and then subtract our exponents. I personally like subtracting exponents first and getting n cubed to the negative third, which is n to the negative 9th. But the other way, like I said, is to multiply them both, or to move the negative third into both. And then when I subtract these, negative 12 minus negative 3 is negative 12 plus 3. So we still get n to the negative 9th. It's just 2 different ways of going about it. This needs to move down to the bottom to get a positive exponent. So our answer is 1 over n to the 9th. Now we're going to start having a little bit more complicated situations, and we'll start using our rules from the previous video as well. So one rule that we want to remember is that anything to the 0 power is 1. So when I see a to the 0 and it's surrounded by a bunch of other stuff, I can just mark it out and think of that like it's a 1. Typically what we want to do when we see a problem like this is we want to look at all the numbers, the normal numbers, 6 and negative 4 and 2 and 3. Those are all going to go together to give us one number, or maybe a fraction. Like 6 times negative 4 is negative 24, and 2 times 3 is 6. So that's negative 4. So all of those numbers come together and just give us a negative 4. And by thinking of it that way, I also dealt with whether or not my answer should be negative or positive. Then we can look at our a's. We've got an a squared that's on top, and we've got an a to the 5th that's on bottom. And so together, that would give us a to the negative 3rd. And then I do the same thing with the b's. We've got b to the 4th, and b cubed are on top. B is on bottom. So we can add the exponents on top and get 7, and then subtract the exponent on bottom and get 6. So that's b to the 6th. And then I'd move the a down to the bottom to give it a positive exponent. So this is negative 4 b to the 6th over a cubed. Other way to do this is to, that's pretty much it. Like you'd write all this together as one fraction and start trying to put the a's together and b's together. No matter what, you're going to end up doing the same thing. So the reason that we're allowed to separate it like this into numbers, a's and b's, is because everything is being multiplied together. There's not any addition or subtraction, is what I mean. And since there's no addition or subtraction, we're allowed to do it in whatever order we want to, as long as we keep the things that are on top, the things that are on bottom. B adds a new issue. We've got a -2 here. Everything inside this parentheses needs to get a -2, and that needs to happen before we start combining with the first fraction, because exponents, or parentheses, depending on how you want to look at this, is first or before multiplication in our order of operations. So the first fraction, I could go ahead and simplify the n's and the m's if I want to. So that'll be 28 n to the -3rd and m to the 5th. So really the n to the -3rd would go on bottom. And then I can say, okay, everything inside that parentheses needs a -2. Since n already has an exponent, it multiplies. And the other things which don't have exponents already just get the -2 power. Now, from here, we can combine our numbers and well, we can't combine our numbers quite yet. The 7 to the -2 needs to move up so that we have a 28 on top, and we have now a +7². That's a really big number, so we could probably just leave it for now. The m to the 5th and the m to the -2, those exponents add together because they're both on top, so that's m cubed. Then n to the -6, maybe I should have left it on top if it was n to the -3rd on top and n to the -6 on top. Those add together to get n to the -9th. And so I move that back down to the bottom so that it's n to the +9th. Maybe I should do 28 times 7², which is 49. 2, 7, 2, 5, 2, 3, 11, 2, 7, 3, 1. So 1372 is our number. M cubed is on top, and n to the 9th is on bottom. There are quite a few different ways that you could go about getting to this answer, but the important thing is that that's the answer you come up with. If you're coming up with a different answer, you're either making a little mistake by just adding badly or multiplying badly, or it could be that you're doing things in the wrong order. So this is just one way of thinking about it that I've shown here.